Good morning to all. In yesterday's lecture, we are starting block diagram representation. In that, syllabus is block diagram, algebra, general representation of feedback control system, transfer function, and rules of block diagram algebra. Okay. So total 8 rules are there. Reduction of block diagram. In that, 6 rules are completed in yesterday's lecture. 2 rules are remaining. See the introduction of block diagram. This is only a pictorial representation of given system. Okay? It is a very simple way to representing the given complicated practical system. It's known as block diagram. See the system of water level indicator with the help of float. So this actual diagram of this water level indicator, and this is block diagram of water level indicator. Then here general representation of closed loop system and transfer function. Okay. So what is mean by transfer function, takeoff point, summing point? See, this is it is called as summing point, means addition point. This is feedback path. Okay. So yesterday lecture these are completed. That final closed loop control system transfer function is R of S moves to G of S divided by 1 plus minus G of S into H of S. C of S means output. Then rules for block diagram reduction. Total 8 rules are there. Yesterday's lecture 6 are completed. First one is the associative law or addition law. Here output remains same, means R1 plus and R2 minus. Here then R1 minus R2 moves forward, R1 minus R2 plus R3. Now change the position of the two summing point as shown in below. R1 plus R3. R1 plus, also R3 is plus. Then R1 plus R3. Then next summing point here plus R2 minus. R1 plus R3 minus R2. Okay. Output remains same. This is associative law. Okay. Then second rule for blocks in series. So, okay, where blocks are connected in series in block diagram, their starting point is multiply with the block, means R into G1, R into G1 into G2, then R into G1 into G2 into G3, means output C of S is equal to R into G1, G2 and G3. Here the output means where blocks are connected in series, considering as input into block value, multiply input multiply in block value. Okay, where blocks are connected in series, then blocks are connected in parallel, considering algebraically considering the sign of these blocks, means R is the input, then G1 here minus sign, here plus sign, here plus sign, means RG1 minus minus RG1 plus RG2 plus RG3. In that R taking R common, G2 plus G3 minus G3. Here the output of these blocks connected in parallel in block diagrams. Here see the description R in bracket G2 plus G3 minus G1, and C is the output. Okay, this is blocks are connected in parallel in the block diagram. Then shifting summing point behind the block, before the block, means this summing point here, this summing point is shifted here behind the block or before the block. Output is C is equal to Rg plus Y. Rg plus Y. Connected in series R into G, Rg plus Y. Here plus Y. Output is equal to Rg plus Y. Then this summing point here, this summing point shifted here. Okay. See the diagram. Summing point shifted here. the output is equal to R into X, R plus X into G. The C is equal to R plus X into G is equal to RG plus XG. Equation number second. Equation number first, C is equal to RG plus Y. Comparing equation 1 and 2, XG is equal to Y or X is equal to Y divided by G. So that the signal Y must be multiplied with 1 divided by G to keep in the output same. If you shifted summing point before the block, when you output keeping the same, you have to change this multiply with 1 divided by G. Okay. Then rule number 5, shifting a summing point beyond the block or after the block, means this summing point after the block, here block, this summing point shifted here. Okay. So this is the output R plus Y into G, means Rg plus Yg. Here output is equal to C is equal to Rg plus Yg, equation first. Then this summing point shifted here. This summing point shifted here after the block, means C is equal to Rg plus X. So this output, equation number 1, C is equal to Rg plus Yg, equation number 1, and C is equal to Rg plus X, means this is before shifting the summing point and after shifting the summing point. These are two equations comparing 1 and 2. Rg plus C is equal to Rg plus Yg and is equal to R plus Y into G. Okay. So after which summing point it is shifted in series all the signals that are summing point. Then sixth rule is shifting a takeoff point behind the block. Okay. Behind the block means this summing point is shifted here. So in this block diagram, output will be the output is equal to C is equal to R into G, or that is Y is equal to RG. Then this summing point, shifted here. This summing point shifted here. Then C is equal to RG. Okay. So Y is equal to R, but it must be equal to RG. So block with transfer function G must be introduced in series with signal taking off after the block. Okay. Today start the rule number 7 of reduction of block diagram. Give the heading shifting a takeoff point beyond the block. Give the heading rule number 7, shifting a takeoff point beyond the block. Beyond oblique after the block, shifting a takeoff point beyond oblique after the block, and draw this diagram. Same block diagram. R summing point, Y is equal to R into R connected in series Therefore, C is equal to output is equal to R into G. Then to shift a takeoff point beyond the block, then value of Y must remain same, but the signal coming out of the block, that is C is equal to RG. Then shift a takeoff point beyond the block. Here, this takeoff point shifted here. C is equal to R into G, but you have to maintain output C is equal to R into G. You have to multiply by 1 divided by G at one block. To keep the value Y constant, it must multiply by 1 divided by G, and the combination would be as follow. While shifting a takeoff point beyond the block, add a block in series with all the signals which are taking off from that point having transfer function as reciprocal of, reciprocal means 1 divided by G, reciprocal of transfer function of the block beyond which takeoff point is to be shifted. Okay, understand? If you have maintained the output C is equal to RG, you have to changes after shifting this takeoff point. This diagram, see this diagram, this takeoff point shifted here, then R into G, therefore C is equal to RG, and after shifting this takeoff point, you have to maintain the output C is equal to R into G, you have to add this block 1 divided by G by using transfer function or reciprocal of this block. Okay, so draw this and write down. Then next, last rule of reduction of block diagram with the heading removing minor feedback loop. Okay, give the heading removing minor feedback loop. Removing minor feedback loop. Okay. So this removing minor feedback loop, considering the eliminating the such minor loops, then summing point, considering only one signal input and one signal output. Okay. So remove of this minor removal of these integer simple forms, this block diagram uh, remove or avoid further confusion for removing the minor feedback loop. Okay, so see the diagram. So R of S plus minus G of S, H of S is the feedback, then output C of S. R of S means reference input, C of S means output, and this is process, this is feedback process. See the final block diagram R of S. So G of S divided by 1 plus minus G of S into H of S here, and then C of S is the output. Okay. So this include the removal of internal simple forms of the loop by using standard result. And after eliminating such a minor loop, if summing point carries only one signal input and one signal output, it should be removed from the block diagram to avoid further confusion. Okay, so draw and write down. Rule number 8. This is the last rule of reduction of block diagram. Draw it and write down. So this is the total 8 rules of reduction of block diagram. and today we are starting new point, modes of control. This is the last point of this chapter. Okay, so total three subpart. First one is the introduction of control system. Second, block diagram representation, and third, modes of control. Okay, so we are going to start third point or last point of this chapter, modes of control. Here the syllabus. First one is on off controller, then proportional P, then integral I, then derivative D. These are the proportional controller, integral controller, and derivative controller. Then P plus I, proportional plus integral controller. Then P plus D means proportional plus derivative controller. And then PID, proportional plus integral plus derivative controller. No numerical treatment, only theoretical part is there. Okay, so simple point of that first point is on off controller. In on off control only two output is there, where is that on and off. So write down this syllabus, modes of control under the heading modes of control. Then first point, on off controller. Give the heading on off controller. Okay. This is the common and simplest form of controller. Okay, it has to control only two position of control element, that is either on or off. Then mode, hence this mode is also called as on off controller mode. And, and this is cheapest controller, often it is limitations are within the tolerance. Okay, so this is the simplest form of controller. Only two output is there, whether it is on or off. Okay, it's also called as controller mode. Huh? So understood? Okay, so write down, a controller is a device when introduced in feedback or forward path forward path of of system, comma, controls the steady state and transition response and transition response as per requirements. As per requirements, such devices converts input such devices convert input to the controller to some other form of error than proportional to error, due to which steady state and transition response get improved. The next para, write down, on off controller is one of most common and simplest mode of controller. Full stop. It has to control two positions of control element, that is either on or off. Hence, this mode is also called as on-off controller mode, on-off controller mode, full stop. It is the cheapest controller and often used if its limitations are within the tolerance. If its limitations are within the tolerance. Okay. The next, this on-off controller mode has two possible output states. First one is a 0% or second one is a 100%. Means whether they are on or off. Only two possibilities there on off controller. Okay. Therefore, P is equal to 0% or P is equal to 100%. Means EP, error of this input, is less than 0 and EP is greater than 0, considering equation first. Okay. If the error rises above a certain critical value, wait for 5 minutes due to discontinuity of electricity. Wait. Due to electricity problem, today's lecture stop here. Place your roll number and leave the meeting.